Okay, so we are on page 389. We're ready to do consumption over time. So let's go ahead and do example number 5, where it says potato consumption. Potato consumption. From 1970 to 1980, the rate of potato consumption in a particular country was that. Number 5, where potato consumption was 2.2 plus 1.1 to the T. And these are in millions of bushels. A lot of potatoes. How many potatoes are in a bushel? Anybody know? You want to look it up? Look at their phone. How many potatoes are in a bushel? No. Bushel is like more like a wooden crate kind of thing, isn't it? It's not the plastic bag. What does it say, Lauren? Okay, so how many pounds?
It's saying that usually potatoes in a bushel is
50 to 60 pounds. So the bags are usually 5-pound bags, right? The bags are usually at the sort of like tens of these, I guess, right?
This might be a huge stock.
So it's like a huge, it must be like a burlap sack type of thing, like a huge burlap sack. Whatever. Okay, anyway, so this country goes through 2.2 plus 1.1 to the T millions of bushels per year, with T being the years since the beginning of 1970. How many bushels were consumed from the beginning of 1972 to the end of 1972? So how many years is that? 2 years, right? Basically, it's from 2 to 4, right? Year 4 almost, right? So it's going to be, I'm going to have to integrate this, right? I'm going to integrate the area. I want the area under the curve of this guy from 2 to 4, correct? That makes sense? Because since this is our equation, right? So years from 1970, right? From 2 to 4. Okay, that's what we're trying to find. 2.2 T plus, this is what? Anybody remember this? It's hard. A to the X. The X is natural log of A to the X plus C. So this would be a natural log of 1.1 over 1.1 T. And I'd have to evaluate this from 2 to 4. So it's like you're going to use your calculator anyway, right? 1.1 to the 4th. Right? You have to put it in. I would put it in the calculator. Right? If you want to save yourself a trip, it could be instead of 1.1 to the 4th, 1.1 to the 4th is the same as 1.21 to the 2nd. You can try that. You can do that if you're going to do it by hand. This is a little easier, I guess. Okay, I don't know. But anyway, so if you do that, the book actually does the mint, because they're a mint type of guy. And they get 7.066. So this would be millions of bushels, right? Millions of bushels. Lots of potatoes. Anybody want to hazard a guess as far as what is America's favorite way to consume potatoes?
Fries.
Or French fries. French fries and mashed potatoes, I think. Those are the two. Ooh, could be potato chips. Yeah. I don't know. I actually had some of the kids do that last a couple of years, 2 or 3 years ago. No. Find out, research what was the favorite mode of consuming potatoes in the United States. Actually, it varied by states, if I remember correctly. So, whatever. Where do most of our potatoes come from in the United States? Idaho. Idaho. Okay, coming and going. Those of you who are taking the test, this is also AP's test favorite question. Okay, AP, so example number 6. At the amusement park from noon till 6, the rate of which people enter in the amusement park in time t is given by E as an enter to E sub t, for which the graph is shown in figure 8.3. So it has that little stick graph there. Where t is equal to 0, which corresponds to noon, t is equal to 6 is 6 p.m. People are also leaving at the rate, but it's leaving at a constant rate of, or continuous rate of that. Okay. If 3,000 people were in the park at noon, so we start from 3,000, how many people are in the park at 6 p.m.? Okay, so how many people have entered between noon to 6? How would I find that? Huh? No, I just asked how many people entered. Not how many left, how many people entered. Yeah, from 0 to 6, you have to find the area under the curve, right? So basically what we're doing, we're counting squares here, aren't we? We're counting squares. So from 0 to 3, so until 3 o'clock, what is the area under the curve? You can't do that on a calculator.
Okay.
No, you can't. You don't have an equation. You have an equation? No. So you have, right? So this is 6. This is 3. And this is what? Tell me, this is 4 or 5? 4. Okay. And this here was 400. This guy was 600, right? So area under this curve, right? This guy is what? It's a, what shape is this? Trapezoid. One leg plus the other leg divided by 2 times the width, 3 hours. Area under this guy here is what? 600 times 1. Area under here is going to be, this is 600. This was 500 divided by 2 times 4 to 6, right? 2. This is how you would find how many people have entered, right? This area under the curve. Area under the curve. Area under the curve. And if you do that, we get 4094. 4094. So this is the amount of people that, all the people that came in. The people who were leaving also. How many people are leaving? What is the rate of leaving? 52 plus t squared e to the something e to the negative t over 5, right? This is the rate they're leaving. So if I want to know how many people have left, I have to find the area under this curve. From where to where? From 0 to 6, right? ET, correct? There's a book in this. I bet you the book in this. Where's the book do? Yeah, they don't, they named it. If you were not going to nint this, how would you do this? pull the 50 out, right? You pull the 50 out. And I can get rid of this guy and this guy. And this guy is easy to do the integrand. It's 2t. I have to take the integration of this, right? How do I do that? So I'm gonna do the tabular form. Derivative, derivative, derivative. Then I have to integrate this, right? 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 And this is why I told you when I taught you this, that the effective, so you're past the effective, you guys forgot this, right? Okay, so this is why, you don't really want to do it that way, but this is the way you're gonna do it, right? In the tabular form, remember doing this? This should ring a bell, right? You just add it together, right? So your n is going to be what? Negative 5t squared e to the negative t over 5 plus, and this is negative, so it's negative 50 e t, 50 t e to the negative t over 5 plus, but it's negative, so it's negative 250 e to the negative 2 over 5. You're going to evaluate this from 0 to 6. Right? If I ask you to do it. The book doesn't do it this way. Obviously, because it's too much work. I just mint it. If you do this, you're going to get 2106. 2106. So this is the amount of people that entered. This is the amount of people that left. And I started with how many people to begin with? 3,000. 3,000 plus 4096 minus 2106, whatever that is, will be your answer. Oh, it says this is not wrong. This is not 4. This is 3,200. So this would be 3,200 to get 4094. Look at the wrong line. We good? You understand that? Okay, so example number 7. I'm not going to go through it. Look at it, read it. It's the same thing. But this is now data. They're giving you data. And this again, AP Calc test. We like to use this. You have to find the area under the curve given the data. And when in doubt, if you don't know what it is, you've got to use the trapezoidal rule, right? Trapezoidal rule. So the trapezoidal rule uses the trapezoidal rule on this data, which you guys have done in internet engineering. Some of you have done it, right? Same thing. Okay. That's that. Let's do the gopher problem. Let's see the gopher problem. This is a little complicated. Seems innocuous, but it really isn't. Okay, so the gopher problem. A 10-mile stretch of rural Minnesota road is bounded on the north by colonies of pocket gophers. Along the road, the density of the gopher population is 500 per square mile. The density increases linearly until it reaches 2,000 per square mile, 3 miles from the road. Find the total population of gophers in this stretch of land that is okay. So I have a road, and along that road, I'm going to have gophers. Gophers are going to be more right by the road or less by the road. You have more gophers or less gophers? So you have more gophers here, this is the road, compared to over here? Or would you have less? Why would they be less if there was less? What happens to gophers that live right next to the highway?
You know,
They die, right? They get squished, right? People run over them. Okay. So you're going to start with 500 gophers per mile, right? Is it per mile or square mile? What is it? Per square miles? Per square mile, right? Per square mile. Okay. And then as it goes higher and higher, after 3 miles, after you go 3 miles away from the highway, at this point you are at 2,000 gophers per square mile, correct? So let us assume a small little strip here, a small little strip here at the very start. Okay. But look at the little strip. That little strip is going to have 500 gophers per square mile. So I have to find the square mileage of this little strip. How long is this strip? 10 miles, right? So it's going to be times 10 miles times whatever the width here, right? I'll call that delta y times delta y. Compared to up here, at the very end, I'm going to have 2,000 times 10 times delta y, right? If there's a delta, same delta y here. Problem is, I don't know what it is in between. Right? I need to come up with an expression that tells me what is the density between here, right here. So when I traveled distance y miles away from the road, what is my density going to be? That's the question, right? So I start with 500. By traveling 3 miles, I get to 2,000. So I start with 500. And then it's going to be some sort, I'm going to have to add to this a certain amount of gain times the number of miles, right? To the point where when I travel 3 miles, I end up with 2,000, right? I don't know what that gain is, but I do know that when y is equal to 3, I end up with 2,000. So what is k? $500. So your expression is going to look like this. This is the density at y miles away from the highway. Okay, so from y miles away, I'm going to go from 0 to y, and I'm going to have 500 plus this guy dy. Okay. Now, obviously, I can't have y when I have dy. Right? I'm not allowed to do that. So I'm going to go from 0 to how many miles? 3 miles. So this would be my question. Well, I have to multiply by 10 here too, right? Let's pull that 10 out here. Because everything is 10 miles wide and 10 miles long, right? Okay, so this is what I'm trying to find. So again, the hard part is finding this guy out. Coming up with an expression here. Okay, once you find the expression, then you just kind of plug and chug and put it in. If I pull 5,000 out, this will be 1 plus y dy 0, 3. 500 y plus 1/2 y squared evaluated from 3 to 0. So it's going to be 3 plus 2 over 1 times 9 times 500. 4.5, 7.5. $37. Yeah. Oh, then I have to multiply that. Oh, it's 5,000, not 500, 5,000. Is that correct? Is that the answer? Yep. Good. Right. Again, the hard part is trying to come up with this stuff. Okay, because it's really, but you have to be able to figure that out. And how am I able to figure this out? By doing the homework. Okay. As you do the homework, you'll be constantly asked this question. Okay, how do I do this? Sometimes it will give you the expression when that just becomes a plug and chug. But a lot of the times you have to know this expression. Okay, so if you want to consider this as, remember when we were doing the koala, the kangaroos, the koala, the kangaroo, we had to come up with an expression of the area, how it worked. Same thing. Last but not least, work. Those of you who are taking my intro to engineering class this morning, we talked about this. We're talking about Hooke's law, right? Hooke's law, or F equal to kx. Equal to kx. And this is when you stretch a spring, how much force it takes to do that. Example number 9. It takes a force of 10 newtons to stretch a spring 2 meters beyond its natural length. So, F is equal to kx, 10 newtons, 2 meters. So k is going to be equal to 5. So the expression of your force is going to be 5x. How much work is done in stretching the spring 4 meters from its natural length? You just have to take the integration of this. So you have to integrate this 5x from 0 to 4 dx. 5 over 2 x squared, 0 to 4. So that's going to be 5 over 2 x squared, 16, 8, 40. Should be 40. Yep. Okay, 40. Pretty simple. Nothing much there. However, you will have some questions on the homework. So make sure you do the homework today so you can ask some intelligent questions before we start on Wednesday. All right, we're good. What?